Hello everyone, today we'll be presenting our COE 476 project. It's an adversarial signature spoofing attack. So now let's run our training loop where we are training our diffusion model on the surrogate, the student. So now we should be seeing a training process of 100 steps due to some no computational capabilities. So now, as you can see, we are starting to get the validation metrics. We are presenting them every 5 steps. So as you can see, SF to R, which is the generated real image from an input fake signature, has uh, has the metrics are 0.345. This is initially a good start. Then we have the SRF, which is 0.286. This is basically the probability, fake is it, which again is promising. For SFR, the lower the better. For SRF, the higher the better, because we are predicting the probability of it being a forged signature. Then we have the SSIM, which is basically how structurally similar is the generated output to the input image. This is to basically see if our generated outputs are meaningful outputs, like not just some random noise. So now, as you can see, the results are not that stable, right? These are just the initial steps, but this is not bad for like the first few steps. With more training, the SFR value should go down and the SRF value should go up. However, again, due to computational limitations, we can only run up to 100 steps. So yeah, so from previous runs, the values of both SFR and SRF do range between 0.25 to 0.5. Now we will be showing you our generated images. Let's look at the latest generated batch. So this is R to F, where we generate a fake signature from an input real signature. Let's see the results. So as you can see, there are some promising results. For example, this right photo here, you can see that we are starting to generate some strokes and some things that are similar to the input image. But we're also generating some random noise that doesn't make sense, right? This is expected. Again, these are just initial steps. But you can see how with more training, it will definitely reach a good result, hopefully. But again, Colab, no computation power, right? So why is the diffusion model doing these random noise? Well, one explanation can be that the diffusion model is just generating anything that will result in the wanted metrics, rather than like trying to make uh, an output that looks like a signature. Again, this will be corrected with time, with more training. Let's see an F to R one. So again, you can see it's starting to make some strokes, something that looks like text, even if it's gibberish. But again, there are still some noise being generated, random noise, which again will be corrected with time. Now we will go to our surrogate training and how we did it, our method. Amar will be presenting that.
Now, as you can see here, this is my surrogate training cell. I am using 20 epochs, and the learning rate for the backbone, which is MobileNet v3 small, 5e to the negative 6. I'm using learning rate for the head 1e to the minus 4, and I'm using some label smoothing for the cross entropy that is paired with the KL divergence loss. I'm using a temperature of 10 to smoothen the teacher probabilities. I'm also using weight decay and an alpha for controlling how much of the KL divergence should influence the learning. Now I'm using here cosine annealing scheduler to stabilize the learning here. And now this is the training. Now, as you can see, the validation is running. Of course, it crashed here because I entered a wrong directory for the history, but it's okay. I'm just demonstrating here how the training loop will work. You have here, this is the loss, the combined loss that we have. We have the KL divergence loss, we have the cross entropy loss, we have the accuracy, we have the F1 score, and the Spearman rank correlation. And then for the validation, we have also the loss, we have the accuracy, the F1 score, and the Spearman rank correlation. And after that, we save the best checkpoint to our safe path that we want. And as we can see here, this is only initially. It looks like the student model is overfitted on the training set just a little bit. But later on, we can see if it actually stabilized or it started overfitting. Thank you very much for watching our video, and goodbye.